Hi, this is Toby, and I want to share with you a bug that I encountered as I was working on the UI framework. Since I'm working on a debugger, I've been paying more attention into how I debug while I was doing my work. In this case, the UI work that I've been doing. And one of the goals of that is to just have a sort of real-world test case scenario for the debugger, as in if I'm going to program something complicated, I for sure will run into some interesting bugs. And I can pit my debugger against those bugs and see how well it fares. So anyway, one scenario came up and I want to show you what the bug was. Okay, so this is the scroll view component. You can use the mouse wheel to scroll up and down. In my case, I'm on a Mac and I'm using the trackpad to scroll this guy up and down. And this is the bug. You're seeing it right now, actually. And it seems to trigger when I just send it lots and lots of scroll events, as in I'm scrolling the thing really, really damn fast. So the error that came was this index out of range. An input is a string and I'm indexing into index 4 and that's out of range. Natural thing to ask is like what is an input? Let's see that, right? So let's see that. And at the moment, this actually takes a while. There was a lot of event for the program to process, generating quite a large log file. So here I'm back at the scene, sort of when the error happened, and I can see the value of the variable. So let's scroll to an input. Now, so an input is this string. And this is a control code that we're trying to parse. A control code is the way in which the terminal is sending me these scroll events. The control codes or the control sequences usually start with a control character, which is this /x1b thing, and it comes with some data. And in this case, an input doesn't have the number of characters that I would expect. So at first, I just thought, that's weird. And if it is indeed that it's possible for the terminal to send me these incomplete inputs, I guess I'll have to like error check that and ignore them or something. And initially, that's what I did. But then I had second thoughts, and I thought to dig deeper. And I went back in here, and I stepped backwards in time. It's going back to the top of the while loop, and then when I keep going, it's actually going again. And I can actually see an input is getting longer and longer. And what is actually going on is there could actually be a variable number of events here encoded. And I can actually see 3 of them repeated here. 1, 2, and 3. And so this while loop's job is actually to go through all of them and parse them. So one of the things that I remember when it was the first time I was debugging this problem is actually you notice when initially I was scrolling down, I encountered tons of these wheel down events here. I just noticed that even though that was not what I was hunting for, holy moly, there's a whole bunch of wheel down events, and I'm not expecting to see that many events. Usually I expect there to be like 1 or 2 events at most. So seeing this many raised some questions. So one thing I can do is like, how big was an input really? Because this is an input can be variable length, and then this while loop breaks it down. So I can go back in time until I hit the beginning of this function. When it just entered the function, I do that via right mouse click on this line. So I've done that. I go back and I look at an input, and I can see it's really, really quite long. And that is why I had lots and lots of mouse wheel events. That's interesting. So, I mean, that's just something I would never have expected. Because from what I've seen in the past, this input is at most 1 or 2 events long, and here I'm getting tons of them. So another question that arose in my head was, hey, well, if this is so long, is it always this long? So I can go back in time again and sort of rewind back to the previous time that this function was called. So I click and I look at how long that one was, and it was also quite long. I do it again, and I rewind back several times, and at one point I got an input that was actually short, and this is closer to what I was expecting. So this gets me thinking. I'm starting, like, a theory is starting to form in my head, right? It seems like the length of this input string is, at some point it's relatively short, and then at later time it's getting longer and longer, and I'm getting the hint that the number of events is over flooding the program. The program isn't able to handle the amount of events that are coming in. In my scroll view, basically, every time there's a wheel event, I'm going to have to perform a repaint. And this repaint is the potentially expensive operation. So if I have tons of wheel events, that means I'm gonna have to call repaint hundreds of times. And the repaint operation is the thing that potentially can be expensive. So the fix I came up with was, I'm going to coalesce the wheel events, many of them, into a single one. And the way I'll do that is I'll make a dictionary, and I'm going to uniquely key this dictionary based on the attributes of the event. I added an attribute to the event called amount. I'm just going to increase that number so that the application, it only gets 1 event instead of 100 events, but it'll get this amount parameter to tell it how much to scroll up, and therefore how much within the view to shift up or down. So this was the idea, and it worked out quite well. So I ran this again after this fix, and now it doesn't matter that I try to scroll really fast, and I don't encounter the bug anymore. So one thing that I wanted to see with the fixed version, if I went back into the function, I looked at the input. Would I get a long input? Or if my hypothesis is correct, then I should get a fairly short input. So I jump into the end of the program, and I'm actually just gonna find that line in the event processing, which is here. Jump back in time into here. Oh, I think I need to go backwards into it. Okay, there we are. And now I'm gonna go back in time into here. This is the Q. This is the Q key that I typed to end the program, but I'm gonna go backwards further. So here are the wheel events. There are actually 3 of them this time. I go back again. 3. This time we have more. 4. This time we have more. And yeah, so it looks like it's not 1 or 2, but it's more like 3 to 5 of these per call into this function. So it looks like we're doing good, but I still want a better picture. I want to be able to visualize better what's actually happening. Like, me sort of clicking through this is a very manual and tedious process. What I would like to be able to do is automate this, and we can. In this case, all we need is a SQL query to query out all the times that the code reached this point, and then I want to see what was the input in there at that point in time, and print it all out. So I came up with this SQL query that does that. I want to compare it when I run it on the version of the database that had the bug in it versus the version that does not have the bug in it. So let's do the version that has the bug in it first. and then I execute the query here. Okay, so this is what we get. Basically, in the problematic program, it hit this line 14 13 times, and this is the length of an input variable for each of those times, and this is the actual value of that variable for those times. So you can see sort of like a historical summary of all the times that the program reached this line, and also a printout of what that variable was at that point in time, and the length of the input. So we can clearly see that the length of the string is getting worse and worse. Anyway, I pasted this data, or this summary, into a file. I called it problem plot. The problem version, we had 9, 18, 18, and then it jumped to 3000 or something, and then I have the whole line here. You can sort of imagine this as a bar graph, if you will. We could have put this into Excel and plot it into these bars, but you can sort of imagine this as these long bars, except these really long ones are getting wrapped. So this is the version that had the problem in it. The one that was fixed, it looked like this. So sometimes the input was longer, sometimes it was shorter, but we're sort of sustaining when it goes up and down, but we're never going to the point of no return. And the longest one in here is probably this one. I'm shrinking the font size so that you can see the big picture, but the longest one is 387 characters long, or bytes long. It was this one. That's still a lot of scroll events, but I think coalescing the events into one helped the performance in this case. I want to summarize some lessons that I think I have learned from this experience. Number one is I was able to go back to the scene of the crime and have a look around. When I saw that very, very long list of wheel down events, I didn't really pay attention to initially, but like I caught that out of the corner of my eye. If you didn't have the ability to step back into all of that programming context, you might not have looked around. If you were to do print debugging, then you would only print the things that you thought were the culprit, and you might have missed out on some other things that you didn't think to look. The second thing is take one thing, plot it over time, which is what we did with the variable here. Hey, there's an input. I want to plot this over time. I want to know what this input was over the lifetime of this whole program. The concept is extremely powerful, and in my case, I was able to like whip up a SQL query in a quick and dirty and hacky way. I think something like this could be built in as a feature to a time-traveling debugger, and it could potentially be very useful. I also think that as a developer, if you know some SQL, you can definitely get in here and write some SQL and get the answer you need. So yeah, so that's the story that I wanted to share with you.